Hello and welcome to a super-powered adventure. Today we're going to explore something you use every single day but might not see very often. It's all about electricity. Think about it. Electricity is the amazing energy that lights up our rooms, powers our video games, and keeps our food cold in the fridge. It's like a secret, invisible force that makes so many things in our world work. But have you ever wondered how this magical energy gets to your house? It doesn't just appear out of thin air. It has to travel a very long way, and it needs some special help to get there safely and with the right amount of power. That's where our stars of the show come in, electrical substations. You might have seen them before. They are those big, fenced-in areas with lots of metal structures, wires, and buzzing sounds. They can look a bit mysterious, maybe even a little bit scary, but they have a very important job. Substations are like traffic controllers for electricity. They help manage the flow of power, making sure it goes to the right places. Without them, the super strong electricity from power plants would be way too powerful for our homes, and it wouldn't be able to reach everyone who needs it. Imagine you're trying to send a letter. You don't just run all the way to your friend's house, do you? No, you take it to the post office. The post office sorts it, puts it on the right truck, and sends it on its way. An electrical substation is very similar to a post office, but for electricity. It takes in a huge amount of electrical energy, sorts it out, changes its strength, and then sends it along the next part of its journey. It's a crucial middle step that makes our whole electrical system work smoothly and safely for everyone. So, why can't we just have one big wire from the power plant straight to our house? Well, the electricity made at a power plant is incredibly high voltage. That means it has a massive amount of push behind it. This is great for sending it over long distances, a bit like using a super powerful hose to spray water very far. But if that super powerful jet of water hit you, it would knock you over. In the same way, that high voltage electricity would be far too strong for your telly or your toaster. Substations are needed to calm that power down before it gets to you. Let's follow the amazing journey of electricity, starting from where it's born. Far away, at a giant power plant, electricity is made. This can happen in many ways, like by using wind to turn turbines, using the sun's rays with solar panels, or using steam to spin a generator. The power plant creates a massive amount of electricity. It's so much power, in fact, that it's given a huge push, or what we call a very high voltage. This high voltage is essential because it allows the electricity to travel a long, long way across the country through thick wires called transmission lines without losing too much energy. These transmission lines are the superhighways for electricity. You can see them stretched across tall metal towers, marching across fields and over mountains. The electricity is zipping along these wires at an incredible speed, carrying all that energy from the power plant. But it's not heading straight for your house just yet. It's far too powerful for that. Its first major stop is a large transmission substation. This substation acts like a major motorway interchange, directing the high-voltage electricity in different directions, sending it towards different towns and cities that need power for all their homes, schools, and factories. After leaving the big transmission substation, the electricity continues its journey on slightly smaller power lines. It's still at a high voltage, but it's getting closer to where it needs to be. Its next stop is a smaller local substation. This is the kind of substation you might see near your neighborhood. This is where the most important magic trick happens. The electricity that arrives is still too strong for our homes. The job of this local substation is to take that powerful electricity and reduce its voltage, stepping it down to a much lower and safer level that we can actually use. Finally, after being made safer at the local substation, the electricity is ready for the last part of its trip. It travels along the familiar wooden poles or underground cables that you see in your street. It might even pass through one more small green box on the pavement, which is another even smaller type of transformer. From there, a wire runs directly into your house, connecting to your fuse box. And just like that, the electricity has completed its incredible journey. Now, when you flip a switch, the power is there, ready and waiting to light up your world, all thanks to the clever work of substations. So, what exactly is inside one of these buzzing substations? Let's peek behind the fence and look at the main parts. The most important piece of equipment, the true superstar of the substation, is the transformer. Transformers are the big, often gray metal boxes that you see, sometimes with cooling fins on the side. Their job is to change the voltage of the electricity. Think of a transformer like the gears on a bicycle. When you're going up a steep hill, you use a low gear to make it easier to pedal. When you want to go fast on a flat road, you use a high gear. Transformers do something similar for electricity. The big transmission substations have step-down transformers that take the super high voltage from the power plant and change it to a lower, medium voltage. It's like shifting from a super fast gear to a slightly slower one. Then, the smaller transformers near your home step it down again, from that medium voltage to the low voltage that your appliances use. This stepping down process is what makes the power safe and usable for us. Without transformers, our electrical system simply wouldn't work. They are the essential link in the chain. Next up, we have switches and circuit breakers. These are like the light switches in your house, but on a much bigger scale. Their job is to control the flow of electricity. Engineers can use these giant switches to turn off the power to certain lines if they need to do repairs, or to reroute the electricity if there's a problem somewhere. Circuit breakers are special, super fast safety switches. If something goes wrong, like a lightning strike hitting a power line, the circuit breaker will automatically trip and shut off the power in a split second. This protects the expensive transformers and other equipment from getting damaged. Of course, with all this powerful electricity around, safety is the #1 priority. That's why substations have lots of safety equipment. You'll see things called insulators, which are usually made of glass or ceramic. They look like a stack of plates or bells. Their job is to stop the electricity from escaping the wires and going into the metal support structures or the ground. They make sure the electricity stays on its proper path. The entire substation is also surrounded by a high fence with warning signs to keep people and animals out, because getting too close to high voltage equipment is extremely dangerous. One of the most important jobs of a substation is making electricity safe for everyone. As we've learned, the power coming from the power plant is way too strong for our homes. A substation carefully and precisely lowers this power. It's like pouring juice from a giant carton into a small glass. You wouldn't just tip the whole carton upside down. You would pour it carefully. Substations do this for electricity, using transformers to pour just the right amount of electrical energy at a safe voltage into the wires that lead to our neighborhoods. This ensures that when you plug in your tablet, it gets the gentle power it needs, not a giant jolt. Substations are also our first line of defense when things go wrong. Imagine a big storm comes and a tree branch falls onto a power line. This can cause a sudden surge of electricity, which is very dangerous. The smart equipment inside the substation, like the circuit breakers we talked about, can detect this problem instantly. They act like a super alert guard, and in less than the blink of an eye, they switch off the power to that broken line. This stops the problem from spreading and causing a bigger blackout or damaging equipment in other areas, or even in your home. This protective role is crucial for keeping the entire electrical grid stable. The grid is the whole network of power plants, transmission lines, substations, and wires that connect everyone. Substations are constantly monitoring the flow of power. If one part of the city suddenly starts using a lot more electricity, say on a very hot day when everyone turns on their air conditioning, the substation can help manage that demand. It can redirect power from other parts of the grid to make sure everyone has enough. This balancing act happens 24 hours a day, 7 days a week, to keep things running smoothly. So, the next time you flip on a light, watch your favorite show on TV, or charge your phone, take a moment to think about the humble substation. These fenced-in areas are the unsung heroes of our modern world. They work silently in the background, managing, directing, and taming the wild power of electricity so that it can be a safe and reliable friend in our daily lives. They connect the giant power plants to our small homes, making sure that the amazing energy we depend on is always there, right when we need it, at the flick of a switch.
Today, we're diving into the heart of electrical power, right here in your university lab. This is where theory meets practice, and where you get to see the magic of electricity unfold before your eyes. This demo substation isn't just wires and switches, it's your hands-on gateway to understanding how electricity travels from power plants to your devices. You'll get to manipulate the components and see how each part plays a crucial role in the bigger picture. Here, you'll move beyond theory, operating real equipment and seeing the results instantly. It's an opportunity to bridge the gap between what you learn in textbooks and how it applies in the real world. This lab is your training ground, safe, controlled, and designed for you to experiment, learn, and build confidence. Safety is paramount, and you'll be guided every step of the way to ensure you understand the importance of each procedure. You'll master the basics of voltage transformation, circuit protection, and the intricacies of how these systems work together to deliver power efficiently and safely. And troubleshooting, skills that power real cities. These are the foundational skills that will prepare you for a career in electrical engineering, making you a vital part of the energy sector. Let's approach this with curiosity and respect. This is your first step into the world of electrical engineering. Embrace the learning process and take full advantage of the resources available to you. Ready to flip some switches and unlock the secrets of the grid? Let's get started. Your journey into the fascinating world of electrical power begins now. Before powering up, let's meet the main components of your demo substation. The power supply is your starting point, feeding electricity into the system. Isolator switches act as gatekeepers, safely disconnecting parts of the circuit for maintenance. The transformer steps voltage down to safer, usable levels. Circuit breakers protect the system, instantly cutting power during faults. Meters, voltmeters, ammeters, wattmeters give you real-time data on system health. Busbars distribute power efficiently, while protective relays detect faults and trigger breakers. Understanding these players is your first step to confidently operating the substation. Safety first, always. Before you even think about starting any work in the electrical substation lab, remember that your well-being is the top priority. Every step you take should be guided by caution and awareness. Before touching anything, put on your PPE, safety glasses, insulated gloves, and closed-toe shoes. These are your first line of defense against electrical hazards and accidental contact. Take a moment to carefully inspect the substation for loose wires, frayed cables, or stray metal objects that could pose a risk. Even small issues can lead to big problems if overlooked. Ensure the area is clean and dry, with no puddles, clutter, or debris that could cause slips or electrical shorts. A tidy workspace is a safer workspace. Know exactly where the emergency shutoff button is located. In an emergency, seconds count, so make sure you and your team can reach it quickly. Confirm all switches, isolators, and breakers are off. This is your safe starting point. Never assume, always check for yourself. Visually check for open gaps in isolators, making sure there's no chance of accidental connection or current flow. Double-check the off positions on all breakers, confirming that every switch is exactly where it should be before proceeding. Always work with a partner or under supervision. Double-check each step together. Teamwork helps catch mistakes and keeps everyone accountable. Discuss your plan before starting. Clarity prevents mistakes. Make sure everyone understands their role and the sequence of steps. In electrical labs, check, double-check, and stay alert. Your safety depends on it. A thorough pre-flight checklist is the foundation of every safe and successful lab session. Time to power up. This is the moment where all your careful preparation comes together. The substation, which has been silent and still, is about to come alive with energy. Every step you take from here is crucial for a safe and successful startup. With all safety checks complete, it's time to turn on the main power supply. Watch for the indicator light. It's your first sign that electricity is flowing into the system. This small glow means your substation is ready for the next steps. Next, close the isolator switches on both the primary and secondary sides. These switches create a complete circuit path, allowing power to move safely through the transformer. Double-check that each switch is fully engaged before moving on. Now, engage the circuit breaker to energize the transformer. You'll hear a solid clunk as the mechanism locks into place. This sound signals that the transformer is now live and ready to step voltage up or down as needed. Check your meters carefully. The primary voltmeter should display the input voltage, while the secondary meter will show a lower output, confirming the transformer is working. Take a moment to compare the readings and ensure they match your expected values. Now, connect your load, such as a bank of bulbs or another test device. Make sure the load switch is off before attaching it to the terminals. This step prevents sudden surges and keeps your setup safe. Flip the load switch on. Instantly, the bulbs should light up, and the ammeters will show current flowing through the circuit. This is a clear sign that your substation is distributing power just as it would in the real world. You've just simulated real-world power distribution, safely and successfully. The energized equipment and glowing indicators show that your system is functioning as designed. Keep monitoring your instruments throughout the process. Watch for any unusual readings or warning indicators. This is how you develop the skills to spot issues early and maintain a safe, reliable substation. Congratulations! You've brought your lab substation to life, mastering each step with attention and care. This hands-on experience is the foundation for real-world electrical engineering success. Shutting down is as crucial as powering up. First, turn off the load, watch the ammeter drop to 0, trip the main circuit breaker to de-energize the transformer. Voltmeters should read 0. Open the isolator switches starting with the primary, then the secondary, creating a visible air gap. Turn off the main power supply, the indicator light goes out. Leave the substation with isolators open. This signals it's safely off. Tidy up, complete your report, and practice this shutdown until it's second nature.
Have you ever wondered how electricity gets from a giant power plant all the way to your house so you can charge your tablet or turn on the lights? It's a huge journey, and one of the most important stops along the way is a place called a substation. You might have seen one before. They are usually fenced-off areas with lots of big metal structures, wires, and machines that hum and buzz. These substations are like the busy traffic control centers for electricity. They are a super important part of the electrical grid, which is the giant network that connects power plants to all of our homes, schools, and businesses. Without substations, the power couldn't get where it needs to go. Think of electricity traveling on a highway. When it leaves the power plant, it's moving at a very high speed, or what we call high voltage. This high voltage is great for traveling long distances, just like a car goes fast on a freeway. But you can't drive at freeway speeds on your own street. Before that electricity can safely enter your home, its voltage needs to be lowered to a much safer level. This is the main job of a substation. It acts like an off-ramp and a traffic light, taking the high voltage electricity and changing it to a lower voltage that is safe for our neighborhoods and all the things we plug into the wall. It's a critical step in the process. Substations do more than just change the voltage. They are also like the brain of the local power grid, constantly monitoring and directing the flow of electricity. They can switch power from one path to another, a bit like a train dispatcher changing tracks. This is really useful if there's a problem like a storm that knocks down a power line. The substation can reroute the electricity around the damaged area to keep the power on for as many people as possible. They are filled with special equipment designed to protect the grid and ensure that the flow of power is steady and reliable for everyone who depends on it every single day. So the next time you see one of those fenced-in areas with all the impressive-looking equipment, you'll know what it is. It's not just a collection of metal and wires. It's a hard-working substation. It's a vital link in the chain that brings electricity to us, making sure it's at the right voltage and flowing smoothly and safely. These hubs are working 24 hours a day, 7 days a week to manage the incredible power that fuels our modern world. They are the unsung heroes of our electrical system, quietly doing their job to keep everything running just the way it should be for all of us. Imagine your family car. To make sure it runs well and is safe to drive, your parents take it to a mechanic for regular checkups. The mechanic checks the engine, the brakes, and the tires to find any small problems before they become big, dangerous ones. Apparatus testing in a substation is exactly like that, but for the electrical equipment. The word apparatus is just a fancy term for all the machines and devices inside the substation. Testing is the process where skilled technicians and engineers give each piece of equipment a thorough health check to make sure it's working perfectly and is ready to do its important job. This testing is incredibly important because the equipment in a substation works very hard. It's constantly managing huge amounts of electrical energy, and it operates in all kinds of weather, from scorching summer heat to freezing winter storms. Over time, parts can wear out, connections can become loose, or insulation can break down. Just like a tiny crack in a car's tire can lead to a flat, a small issue in a piece of substation equipment can lead to a big problem, like a power outage that affects thousands of people. Regular testing helps us find and fix these tiny issues early on. Apparatus testing is all about being proactive rather than reactive. Instead of waiting for something to break and cause a blackout, engineers use special tools to look inside the equipment and measure how well it's performing. They are like detectives looking for clues that might signal a future problem. These tests can tell them if the oil inside a transformer is still clean, if a switch can open and close fast enough, or if the insulation is strong enough to prevent electricity from escaping. By catching these things early, they can schedule repairs at a convenient time, preventing unexpected failures and keeping the power flowing reliably. Ultimately, apparatus testing is a promise of safety and reliability. It ensures that the substation can handle its job of managing our electricity without any surprises. It's a critical part of maintaining our entire power grid. When the equipment is healthy and working correctly, the substation can safely manage voltage, protect the grid from faults, and keep delivering the power we need for our daily lives. These checkups are essential for keeping our electrical systems strong, stable, and ready to power our communities day in and day out, ensuring our world stays bright and connected. Inside a substation, there are several key pieces of equipment that get the most attention during apparatus testing. The biggest and often most important are the power transformers. You can think of a transformer as the main voltage changer. It's a huge metal box, often filled with special oil to keep it cool, that takes the super high voltage electricity from the main power lines and steps it down to a lower voltage. Testers will take samples of that oil to see if it's still clean and effective. They also run electrical tests to make sure the internal wires, called windings, are in perfect condition and that the transformer isn't losing any energy. Another star of the show is the circuit breaker. A circuit breaker in a substation is like a giant, super-fast safety switch. Its job is to protect the grid. If something goes wrong, like a lightning strike or a fallen tree on a power line, the circuit breaker instantly trips and stops the flow of electricity to prevent damage to other equipment. During testing, engineers will measure how fast the breaker can open and close. It has to happen in the blink of an eye. They also check the mechanisms that operate it and ensure its internal parts are clean and ready to act at a moment's notice to keep the grid safe. Of course, we also have to test the switches. While circuit breakers are for emergencies, switches are used for routine operations, like redirecting power or isolating a piece of equipment for maintenance. They are like the light switches in your home, but on a much, much bigger scale. Technicians will test these switches to make sure their metal contacts are clean and make a solid connection when they are closed. A poor connection can cause the switch to get very hot and waste energy, so ensuring they work smoothly is very important for the substation's overall health and efficiency. They need to open and close reliably every time. Finally, there is a whole system of protective relays. These are the brains of the substation's safety system. Relays are smart devices that are constantly monitoring the flow of electricity. They are programmed to detect problems, like too much current, and they are the ones that tell the circuit breaker to trip. Testing these relays is extremely important. Engineers use special equipment to simulate a problem, sending a signal to the relay to make sure it sees the fault and sends the command to the circuit breaker at the correct time. It's like a fire drill for the substation's safety system. Working in a substation is a job that requires extreme caution and a focus on safety at all times. The amount of electricity flowing through the equipment is incredibly powerful and dangerous. Because of this, safety is the #1 priority during any apparatus testing. Before any work begins, the team holds a detailed safety meeting to discuss every step of the plan. They identify all the potential hazards and make sure everyone on the team knows their specific role. They follow a strict set of rules and procedures designed to keep everyone safe from the high voltages present all around them. One of the most important safety steps is called de-energizing. This means the equipment that is going to be tested is completely disconnected from the power grid. You would never try to fix a toaster while it's still plugged in, and the same idea applies here, but on a massive scale. Technicians use switches to isolate the apparatus, and then they apply safety grounds. These are special cables that connect the equipment to the earth, ensuring that no stray or unexpected electricity can flow through it and cause a shock. This creates a safe work zone where the team can connect their testing instruments without risk. The technicians themselves also wear special protective gear, known as personal protective equipment, or PPE. This includes things like hard hats, safety glasses, and flame-resistant clothing that can protect them from an electrical flash. They also use insulated tools and gloves that are designed to stop electricity from passing through them. Every piece of equipment, from the testing devices to the safety gear, is inspected before use to make sure it is in perfect condition. There is no room for error when you are working with so much power, so every precaution is taken very seriously. By performing these tests safely and regularly, the technicians and engineers are doing more than just maintaining equipment. They are ensuring that the entire power grid remains stable and reliable for all of us. Each successful test is another guarantee that the substation can handle storms, surges, and the daily demands we place on it. This careful, behind-the-scenes work prevents widespread blackouts and keeps electricity flowing safely to our homes, hospitals, and schools. So, the next time you flip a switch and the light comes on, you can thank the dedicated crews who work safely to test our substations and keep our world powered.